Welcome to myprojectbazaar.com. Our project title is Host-Based Intrusion Detection for VANETs, a statistical approach to rogue node detection. Abstract. In this paper, an intrusion detection system for vehicular ad hoc networks is proposed and evaluated. The IDS is evaluated by simulation in the presence of rogue nodes, that is Addons, that can launch different attacks. The proposed IDS is capable of detecting a false information attack using statistical techniques efficiently and can also detect other types of attacks. First, the theory and implementation of the VANET model that is used to train the IDS is discussed. Then an extensive simulation and analysis of our model under different traffic conditions is conducted to identify the effects of these parameters in VANETs. In addition, the expansive data gathered in the simulation are presented using graphical and statistical techniques. Moreover, RAG nodes are introduced in the network and an algorithm is presented to detect these rogue nodes. Finally, we evaluate our system and observe that the proposed application layer IDS based on a cooperative information exchange mechanism is better for dynamic and fast-moving networks such as VANETs as compared with other techniques available. Let us see the proof of our project. First, we have to form VANET model, that is nothing but vehicular ad hoc network model. In that model, we have to form green shield model. That is, green shield model is used for calculating the speed density of the network. That is nothing but we have to calculate speed of the node and the density of the node. Density of the network is our network have 50 nodes, so our network density is 50. We have to introduce another one model is nothing but attacker model. That is, rogue nodes are identified. These rogue nodes are identified by using our obstacles or abnormal condition. We have to check our normal node information with the abnormal condition. So in that case, we have to use intrusion detection scheme for calculating the intrusions. That is rogue nodes. Rogue nodes are two types. First one is false identification problem and Sybil attacks. So these kind of attacks are identified by using intrusion detection scheme. If the rogue nodes are identified, we have to data calculation is done via bypassing node, else the data collection is done via the access points. Then we have to analyze the simulation result from the output of .tr file. That is, we have to analyze our trace file using simulation analysis. In that, analyze the scalability, throughput and delay PDR of the net. Let us see the output of our project. First, open the VMware workstation. This is running our NS2 file. So in that, we have to click this terminal window. It is corner of the page. So click on this. That type cd space our project name. So we have to change our directory to our project name. This is the syntax for running our project file, that is TCL file. TCL is nothing but tool command language. For that, type ns space main.tcl. When we type this, it will show number of nodes used in our project and intrusion detection check is also done. So intrusion detection is nothing but we have to check our process with the abnormal leavings. So our node informations are stored in one table, that is we have to store our all the process in one routing table. Obviously we have to check the process in sequential manner. That is, our stored information is checked with the abnormal leaving situations. So if the node have such situation, we have to select we have to declare that node is act as a rogue node, and we have to bypass the information to another node. So now the current time and abnormal leaving, transmission higher power, reception higher power, abnormal leaving and lower leaving bandwidth efficiency are calculated using the intrusion detection scheme. After 30 seconds, it will produce one NAM window, is nothing but network animator window. This is our output file. So now the process is running in there is 17 seconds. After there is now 10 seconds remaining. So after 10 seconds, now is in current time is in 20 seconds. So after 10 seconds, it will produce our output file. So this is calculate through the lifetime. That is, when we start the process and when we end the process, we have to start the process on 0 second, and we have to end the process on 30 seconds. So all the details are what are all the informations, obstacles informations are dictated in this place. So after our timing schedule finished, it will produce our NAM file. When we click on this play forward button, it will works. This is for increasing or decreasing the speed. So we have to set the speed as 20 milliseconds. First, our bandit model is created. This is our bandit model, which contains 25 nodes. So 0, 1, 2, 3 nodes are act as access points, and all other nodes are act as a source node as well as neighbor nodes. Now the node 5 and 6 are transform the information to the access points, as well as all the nodes are transformed the information to their access points. When any obstacles is arrived, it will the node is depicted as rogue node. Now the information, now this node is act as a rogue node, and it will lose the packets. So this is our packet dropping ratio. So the rogue node drop all the packets. So our intrusion detection scheme identified this abnormal condition. So we have to transform it in another way. For simulation analysis, we have to run our graph, which is extracted from .trace file. So type GNU plot space graph1.plot. This will produce our number of vehicle versus packet delivery ratio. So this is our packet delivery ratio, trust and IDS mechanisms. So trust is existing system, and we have to propose IDS. So our packet delivery ratio is higher than the existing trust method. Thank you.